The topic is reversing the order of integration for double integrals. So let's do the first example. Reverse the order of integration by sketching the region of integration of this double integral. Alright, according to the double integral, since we have a dx outside, let's do this. Since the dx outside, these are x values. So we know that x is going between negative pi over 2 to pi over 2, and then the y is going from 0 to cosine of x. So how do we sketch this region? Here's negative pi over 2. Here's pi over 2. We're going from 0. This is y equals 0. Cosine of x is how the cosine of x look like. Right? This is, well, the whole thing is y equal cosine of x. Right? Of course, I mean, if you want to graph more of it, it keeps going that way and so on. Alright, so how do we reverse it? Now, so this is already type 1, right? Type 1, y is going from g1 of x, which happens to be 0, to g2 of x, happens to be cosine. Now we need to reverse it to type 2. So we need x. So x is going to go from here. Well, let's start from y. Y is going from 0 to 1. So that's easy, right? Y is going to go from a number to a number. Now the x, this is where the problem is. X is going to go from here to here. Right? So we need to find the equation x equal blah blah, and then the equation here x equal blah blah. So of course y equal cosine of x, we need to solve for x, right? So let me do it here. Y equal cosine of x. By the way, we're going to get cosine inverse, but remember, cosine inverse function is for restricted function cosine of x such that x is between 0 and pi. So when y equal cosine x, x between 0 and pi, this means that x is equal cosine inverse of y. And of course y here is between negative 1 and 1. So basically, if we pick, where's the x? So this is the x. So if we pick, so this will be x equal cosine inverse of y. It will be this part. In other words, this x. This distance. This is x equal, because it's between 0 and pi over 2, which is between 0 and pi. So this will be x equal cosine inverse of y. Now, what about this function? Think about it. For the same, so we're picking this x and y. So this distance is equal this distance, except that it's negative. So this one is supposed to be x equal negative cosine inverse of y. So if you pick a y here, this will be cosine inverse, this will be negative cosine inverse. So my x is going to go from negative cosine inverse of y to cosine inverse of y. So let's rewrite the double integral. Let's call this example 1. So 1 will be equal to, now the y is going to go from 0 to 1. The x is going from negative cosine inverse of y to cosine inverse of y. And it's f of xy. F of xy is not given, we don't care. So instead of dy dx, this time we're going to do dx dy. And we're done. They're only asking us to reverse and don't have to evaluate. Alright. Now next integral, again, I need reverse the order of integration. So I need to find, I need to sketch my region of integration. So I know since the dx is outside, I know those are x values. So I know my x is going from 0 to 1. and I know my y, I is going from negative x to x squared. So I need to graph y equal negative x between 0 and 1. What does it mean? When x is 0, y is 0. When x is 1, y is negative 1. So 0, 0 is here. 1, negative 1 will be right here. This is 1, negative 1. Now again, I need to graph y equal x squared when x is between 0 and 1. When x is 0, y is 0. So again, I have this. When x is 1, y is equal to 1 squared, which is 1. And I know this is a parabola. Right? So the x between 0 and 1, from here to here, and the y is going from here, from negative x to x squared. So I have this region R. Right, now I have a problem. When I do the double, when I try to reverse, I can't go these two functions. There's this one and that one. So first I need to solve. In other words, I have to rewrite it into R1 plus R2. So this will be R1. This region will be R2. It's a mess, I can't see that much. That good. Alright, so let's y equal x. So if I solve for x, y equal negative x. If I solve for x, x will be negative y. So that's this one. What about this one? This is y equal x squared. When I solve for x, y equal x squared. When you solve for x, you get minus or plus square root of y, but because this is positive, so it's x equal square root of y, because remember, x here, let me just do it here, this is x positive and this is x negative, right? In other words, x equal minus square root of y will be this. We don't need it. This will be x equal minus square root of y, the left side, just like what we did here on the first example. Alright, so now I have to treat this as two regions. In other words, I have to write two as two double integrals. The first one goes from, the y goes from negative 1 to 0. The y goes from negative 1 to 0. Right? And the x goes from here to here, which means from negative y to square root of y. And this is f of xy. Remember, this is not dy dx, now it's dx dy. Plus, now for region R2, I need to go from 0 to 1. So the y goes from 0 to 1. But the x goes from square root of y to... Oops, by the way, did I mess up on that one? Anyway, let me put that one from square root of y to 1. Yeah, I messed up here. For the first region 1, it goes from minus y to 1, right? I mean, that's obvious, to y equal 1. I mean, to x equal 1. From x equal negative y to x equal, this is, let me write it, this is x equal 1. It's the same line, x equal 1. Alright, and then it's f of xy dx dy. Yep. I mean, let me just do it here very quick just to show you the region. This is what I meant with R1. This is what I meant with R2. This is negative 1, 0, 1. For this integral, we went from negative 1 to 0, and then we went from, this was x equal negative y, and this was x equal 1. Right? See, x equal negative 1 to negative y to 1. And then we went from 0 to 1, from this to that, and then the y went from, this is x equals square root of y, and this is x equal 1. And that's it for these two examples.